So now that we've talked about synchronous programming and synchronous operations, let's turn around and talk about asynchronous programming and asynchronous operations. And we'll start by explaining what asynchrony is as a set of concepts, and we'll see how you can use them in practice. So asynchrony is a means of concurrent programming where the caller does not block waiting for the callee to complete. Remember, synchronous programming is where you blocked. And a great example of asynchronous interactions or operations is dropping a letter into a post box or at the post office, where you're not going to sit around waiting for the letter to come back. I mean, you could, but that would be silly. An asynchronous call immediately returns something called a future, and we'll see there are different variants of futures, while the computation runs in the background concurrently with respect to other operations. So you can see here we're going to make a call from the caller to the callee. It returns a future right away, and then the callee does its thing, but the caller doesn't have to wait for the response to come back, doesn't block. So it's independent of the callee's behavior is independent of the calling threads or the caller's threads flow of control, caller threads flow of control. And an example here might be something where you go and order some food at a fast food restaurant, and you don't have to wait for the food to be cooked. You can go off and do something else, and then when it's done, you get the order delivered to you somehow. So you don't have to wait at the cash register for the food to be cooked. You can go off and do other things while you're having your operation performed. The future that is returned by making a call that's asynchronous will be triggered when the computation completes. So typically what happens is you make a call, you get back a future, and the asynchronous call runs, the asynchronous operation runs in the background, and when it's done, then the client can redeem the future when it's complete. It'll be triggered, and you can get the results back somehow. And we'll talk about different ways you can get the results back here shortly. The client may or may not block waiting for the result, depending on various factors. It's usually not an appropriate thing for a caller, a client, to invoke an asynchronous operation and then immediately block waiting for the result. That completely defeats the purpose of using asynchrony if you're going to block right away, because then you might as well have just made a synchronous call as opposed to an asynchronous call. There's a whole bunch of different examples of this. One that I like, but unfortunately has been deprecated, was Android's async task framework, which allowed background operations to run asynchronously, hence async task, and it would eventually publish the results on the user interface thread without the programmer having to manipulate threads or various kinds of other lower level features that were available in the underlying Android framework. So the way it worked was you'd start an asynchronous operation by calling the execute method, and then operations that ran in the background could block, but that wouldn't block the user interface thread, which would give you the dreaded application not responding exception. And then at some point, the user interface thread would be notified based on what happened, whether it completed successfully, whether it completed in a failed way. You could also find out the progress of the async task. And this allowed the programming abstraction, the async task, to shield the client from all the low-level details of programming with futures and asynchronous flows of control and so on and so forth. Like I said, this is a cool feature, but they deprecated it. All right, so that's the end of the overview of the concept of asynchrony. So now that you've seen just a little bit about asynchrony and asynchronous operations, let's once again evaluate its pros and cons, and we'll see that this will motivate the need for other mechanisms like completable futures to address the cons that we're going to show here. So let's start out by talking about some of the good things about asynchronous operations. First, they can be responsive. They can make your program responsive, and that's because the calling thread or the caller doesn't need to block waiting for the asynchronous request to complete, which makes things more responsive, hopefully, if you do things right. You can also make systems more elastic because you can have multiple requests running in the background, scalably and concurrently on multiple platform cores, multiple processor cores, things we've been talking about for a long time, which allows you to leverage parallelism that's available in today's multi-core systems more seamlessly and transparently. This elasticity is also important in cloud environments, as we've talked about before. Java's completable future framework, like Java parallel streams, like Java reactive streams, out of the box is not available in a cluster or cloud, but you can connect it to cloud programming resources if you spend a little bit more time using features like WebFlux, which we'll talk about in my spring course. But of course, not everything is rainbows and unicorns. There are some downsides to doing all this stuff. So one issue, whenever you start doing things that are asynchronous, your system may become more unpredictable because there's inherent non-determinism. So non-determinism means you don't necessarily know, looking at your code, how exactly it's going to work and how exactly it's going to perform. Things don't run in lockstep. They run when they feel like running, when the scheduler decides to run them. And this is a problem in general, or an issue, not necessarily always a problem. Sometimes it's a feature with concurrency in general, not just with asynchronous programming, but it's something to be aware of. Another tricky issue with asynchrony is that results can occur in a different order than the original calls were made, which again leads to unpredictability. So if you don't care the order in which the results come back, then this unpredictability and asynchrony is fine. If you do care, then you're going to have to keep track of the results somehow and then order them. And by the way, we've alluded to this earlier when we talked about the way in which Java parallel streams can either have operations that run in the apply phase, run in a way that preserves in counter order, that's the order that things were invoked, or not, be unordered. And if you need ordering, then it takes additional time and effort to order stuff somehow, although that's done for you by the parallel streams framework. Another tricky issue with asynchrony, which is also an issue with concurrency in general, is programming and debugging becomes more complicated. So many people are much less familiar with how you debug and how you program with asynchronous programming. It's just not taught very well. It's not taught very much. We're going to teach it here, but most people don't have that luxury, so they don't really know how to use it. They know if everything works, it runs well, but if it doesn't work, they're like, where do I set breakpoints? How do I figure out what's going on? And there's all kinds of challenges, mostly because of the fact that you don't have your call stack done in a synchronous manner. Things appear and they run sort of wherever they happen to run, and the call stack isn't always going to be intuitive when you have to debug things. There's a nice article here that talks about some of these issues. Another big problem, which is something, of course, that Java attempts to remedy, is that programming asynchronously without proper abstractions leads to something known as callback hell. And if you take a look at JavaScript without the right features in it, you can end up with this horrible, very complicated nested callback model, which is very difficult to program. So this is called callback hell. And you can also have to deal with the unpredictability of when things go wrong. And again, this is not a problem just with asynchrony. It's a general problem with concurrency. Things occur in different ways at different times. And in fact, as we've talked about before, the very act of debugging can also make your program behave differently, which makes it difficult to track down bugs stemming from timing errors. So these are some of the challenges. So let's talk about the pros and cons of this. So in order for the pros of asynchrony to outweigh the cons of asynchrony, we have to look at other factors. So one is, if you're going to go to all the trouble to learn to do asynchronous programming, you'd better get some kind of benefit for the extra effort. And in particular, you want to make sure that the complexity leads to better performance. And indeed, in some cases, it does. And we'll take a look at some examples later that show how this works. So if you play your cards right, you can get much better performance with asynchrony because the programming abstractions, while more complicated to program, are more scalable and efficient when run on a multi-core platform. Another thing that does help, is that you want the programming model to reflect some of the principles we've talked about, or all the principles we've talked about, with respect to the reactive paradigm. So responsive, elastic, resilient, message-driven, and so on and so forth. The nice thing is that Java's completable future framework gives you this programming model that performs well and supports the reactive paradigm. However, as we will see when we get to that in probably a couple weeks, reactive streams frameworks, which explicitly bake in both asynchrony and essentially streaming into the same programming model are even better to support reactive programming. So completable futures are a step in the right direction. They're very useful. You can combine them with Java streams, but there's other abstractions that are even more seamless with respect to supporting asynchrony, and that is reactive programming, which we will get to. So that's the overview of the pros and cons of asynchrony.